Most functions have different slopes at different positions. Here the slope of f of x increases with increasing x. If we take the slope at a point, making it smaller and smaller, we eventually get down to the derivative of a function at point x. Between 2 points, xi and xf, we can sum up the total area under the curve by summing up a lot of little areas. The integral just adds up many small areas, and the more we have, the smaller the error. By taking narrower and narrower areas, the error gets smaller and smaller. Energy is conserved and can take many forms. Mechanical energy is concerned with the energy of the position of an object. Potential energy stores work and depends upon the position of an object in a force field. In this part you should understand whether work is positive or negative with respect to the system or the surroundings. You should also understand the difference between conservative and non-conservative forces. In a gravitational field, the upper position has more potential energy than the lower position. The ball accelerates under the force of gravity as it falls from a height, and the potential energy is converted to kinetic energy. The kinetic energy of a falling ball can be used to do work. To return a ball to its original position, we must do work to raise it up. Some paths require more energy than others, but the only consideration in storing potential energy in the ball depends upon how high it is raised up. The conservative force path just depends upon the change in position of the ball. It has greater potential energy when raised up than in the lower position. If the ball falls, only the potential energy is changed into kinetic energy. Change in position is relative. It does not matter where we define x equals 0. The distance traveled is always 10 meters. Note that there are many different work paths to get the ball back to its starting position. All these paths, except the idealized conservative path, expend more energy than the 98 joules needed. This wasted energy is due to non-conservative forces like friction, sound, heat, etc. Conservative forces only depend upon position. When nuclei decay and become more stable, they emit particles. Here are some common processes. An alpha particle is a helium nucleus, so it has 2 protons and 2 neutrons, with an overall charge of 2+. When an alpha particle is ejected, the mass of the nucleus falls by 4 atomic units, and the charge falls by +2. A beta particle is a name given to an electron that is ejected from a nucleus in nuclear decay. When the beta particle is ejected, the number of protons increases by 1, and the number of neutrons decreases by 1. A positron can also be emitted. This has the opposite effect to beta emission, raising the number of neutrons by 1 and lowering the number of protons by 1. Electron capture has the same effect as positron emission. Nuclei have quantized energy level structure, but the energies involved are many orders of magnitude greater than the energies of valence electrons. When a nucleus undergoes such a transition, the energy has a very short wavelength and lies in the gamma radiation range.